2019 question 5 in the junior cert was coordinate geometry. Write down the coordinates of the shop, home and school. Just be careful, take your time again. Question 5 was worth 10 marks for part A and B. So the shop, we start in the middle, back to -3 and up to 1. So the shop is -3 on the x, 1 on the y. Home next, out 4 and up 2. I would always get you to jot these. Triangles, we can see the slopes, we're probably going to need them. And then school is also out 4. Continue this as a dotted line here and join it to the origin. And we've gone up 5 for school is out 4, up 5. And we said home was out 4, up 2. So let's see the next part. We're told the library is the midpoint between home and shop. So write down your 2 points from below. 4, 2 for home. Shop, 4, 5. And we're asked to find the midpoint. The way I tell my students, add them together to get 8, 7 and divide by 2. So you don't need the formula. 4, 3.5 is the midpoint. And we're told that that's the library. And we're just told to write down the coordinates. So just write down the coordinates. So the next part is the distance between home and shop. We'll just have a quick look at the diagram that would create this distance, the hypotenuse. So we have a 1 here, and we're running all the way along here. We're running 3 and 4, so the run is 7 and the rise is 1. That distance, as you guys know, will be the square root of 7 squared plus 1 squared, which is equal to root 50. And we're asked for this as a decimal. And that's 7.07 centimeters on the diagram. 12 centimeters here. Put your units in and show you're working out what we've shown it above. So scale is next. We're told the distance on the diagram, because obviously we don't live 7 centimeters away from the shop. From shop to school is roughly 8 to 1. And the diagram, the scale is 1. So 1 centimeter will be 2,500 centimeters. Work out the actual distance from shop to school. So I'm just going to write the 2 points down again. Shop to school. But visually it's easier to look at the diagram. So let's go back and have a look at the diagram for shop and school. Bring this information up. We're actually given the distance, 8.1 centimeters. And just reread the question. So we don't need the diagram, it's just 2500. 1 centimeter is equal to 2500, so 8.1 centimeters. Multiplying these, 20250 centimeters. And then we go back, we look at our units. Meters, divide by 100, so 2 decimal places would leave 202.5 meters for the distance. There was 5 marks for D and E together. E, cleaning walks from shop to school, so the same as the previous part. Shop to school. Explain why the distance she walks is probably more than the actual distance. So an explanation required. So the shortest distance is the perpendicular distance. Shortest distance. Why may she not walk the shortest distance? Well, it may contain buildings, obstacles maybe, and you could expand on that a little bit. So it may contain buildings or obstacles, so she may have to take a slightly different route than the shortest route. In part F and G, they've given us the diagram again. We're asked to work out the slope of the line L and then the equation of the line L. All these classic coordinate geometry type questions. So let's create our triangle to get the slope to rise over the run. So the rise starting at 1 and ending up at 5. The rise is 4 if you want to do a separate triangle. The rise is 4. The run from 3 to -3 to 4 is jump to 3 and 4. As you can see, we've seen this already, 7. So if we want to work out the angle A, we could. And if we want the slope, we can also get it. The rise over the run. And then the slope is positive here. It's climbing, so we don't need the formula. Equation of L, y minus y1 equals m, which is why we always have to work it out, times x minus x1. Pick one of your points. Doesn't matter which one you pick. You can try both if you want, but you'll get the same answer. 4, 5 is the one up above. And m is equal to 4 over 7. So y minus 5 equals 4 over 7 times x minus 4. Multiplying by 7, I'll just come up here. We're going to get 7y minus 35 equals 4 times the right hand side. It'd be 4x minus 16. And they tell you they want everything on the same side of the equal sign. So leaving the 4x and bringing the other stuff across, 4x minus 7y minus 16 plus 35 equals 0. So 4x minus 7y, that's going to be plus 19 equals 0. So if you're asked to calculate A, B, and C, your A will be equal to 4, your B will be equal to minus 7, and your C will be equal to 19. And there were 5 marks for F and 10 for G. That's the end of the coordinate geometry question. The last part, you were told to use trigonometry. So slightly different coordinate geometry, but all connected. Work out the size of the angle A. We've got the two straight sides, so we're going to use tan. The tan of A is equal to opposite 4 over adjacent O over A. So the inverse tan of 4 over 7. You type into your calculator, as you have done hundreds of times at this point, the inverse tan of 4 over 7, and we're looking for it correct to 1 decimal place. Getting 29.7 degrees. And in the marking scheme, H was with G. They were both 5 together. So marked very low, this one. Question 6, we've got geometry, angles M, K, and N, and we've got equilateral triangles, so all the angles in this triangle and all the sides are the same. So why don't we label it? This is going to be opposite, so these are all K. And then this is an equilateral triangle. All these sides are the same, but all the angles in here are also going to be K. And we're asked to label these types of angles, so acute, reflex, and obtuse, the way I taught it to you. Acute, obtuse, A, O, or in alphabetical order is the sizes. So acute is 0 to 90 if you want to think about it in just simple terms, 90 to 180, and then greater than 180 is the way these work. So acute is going to be the small one, 0 to 90 is going to be K. The next one, 90 to 180, is going to be M, obtuse, leaving N as the reflex one. You can see it's bigger than 180 here, because here this would be a straight line. And then work out the size of each angles, K, M, and N. And remember that two triangles are equilateral. So we're looking for K, M, and N. So if they're equilateral, well, mathematically, we'd say 3K is equal to 180. K equals 60. So we put the 60 in here. So K is 60. M is a straight line with K from this part here. So M plus K equals 180 if you want to write out the equation. And if K is 60, M plus 60 is 180. And you should see at this point that M is equal to 120. 120. We should put a little degree into at the end. 120. And if we form an equation for n, what's going on here? We have a circle n, and so what have we got here? We have corresponding angles and alternate angles. So this one is alternate with this k, and if we put a k in here, it corresponds with this k up here. So we have 3k and n. 3k plus n is a full circle, 360. We know that k is 60 already. You could do this a lot quicker than this, but I'm just showing you every step. So we're going to have 180 plus n. Will be my 360. And this is the point where you should see your mistake. So if we look back at the diagram, we have n is this bit, but n is also here. So just by maybe putting too much information on the diagram, I've made it a bit unclear. So let me just do that again. I have a k, and a k. So my equation is n plus k, or if we just create our straight line, we could have that maybe separate it, and we get in this, we could write n as 180. And what we're looking for, n plus k is equal to 180 plus 60. I made a bit of a mess of it, but get to 240 in the end. 240 for n. In part C, the two equilateral triangles are not the same size as each other. We can see that from the diagram. Siobhan says the two triangles are similar, but they are not congruent. So we're asked in part 1, give a reason why the two triangles are similar. Similar triangles have equal angles. Similar triangles have equal angles. I think this is enough. And therefore, equilateral are similar. I think that's enough information here. And then part C, part 2, give a reason why the triangles are not congruent. So not congruent. Normally we're congruent, we're looking at side angle side, side side side, that type of thing. So congruent triangles, I'll write it here, are same size. Same, if I can spell it, same size. These aren't. Therefore, write the words not congruent. Part D, the small triangle in the diagram has side length 4, and the big triangle, the side length 8. Use this information to construct the diagram in the space below and show clearly any construction lines used. So constructing triangles, we normally will draw a line of 8 centimeters. We'll take our compass out. We'll put the point of the compass here, and we'll do an arc of 8. So the arc will go kind of in this direction, and then we'll just do our dotted line for now. And then we put the point of the compass here and do another arc, and where these arcs cross, we can say that's equivalent distance. So these two are going to be 8, and then we construct our triangle. So do that for the shape of this diagram. Nice easy construction for part D. And the marking scheme for this question was 15 for part A, 5 for part B, and 10 for the construction here in part D. Question 7. We have a triangle, one side of length 10, another side of length x. The perimeter of this triangle is 26. Find the length of the third side in each case in the table below. So in this triangle A, Hard to believe they're asking for perimeter. In A we have 10, 4. 10 plus 4 is 14. Show your workings. I know you can see the answer is 12. Show where you're getting the 12 from. 26 minus 14 is 12, and you put the 12 in here. The units are beside it. In this one we have 10 plus 9 is equal to 19. 26 minus 19 is equal to 7 centimeters. In part B, there was 10 marks for A and B, but there was only 2 for part B really, because there was 8 marks for one correct part. Most people got part A correct. So what are the properties of triangles? If one side is fixed at 10, the other two have to add up to 16. The perimeter is 16, so let's just jot these down. The other two sides, call them X and Y. I think maybe not just this question, but just understanding properties of triangles. For them to add up to 16, 15 and 1, 14, 13, I'll write them all out. They start repeating. Just to see the pattern here. So we should be able to get the properties of triangles from this. So we have a side length of 10. We imagine the 15 and the 1 here. If I put a side length of 15 from this point, it's gonna, if I put it down exactly flat, it's gonna go 5 centimeters past it. So there's no way a 1 will fit between this point and this point, so that can't work. So if the 15 and 1 doesn't work, same reason 14 and a 2 wouldn't work. The 13 and the 3, if we put a 13 exactly flat against the 10, it'll go 3 past, it'll just create a straight line. So that doesn't work either. So now we're into the properties of triangles. So A plus B, 2 sides of a triangle have to be greater than the third side. So for the first scenario here, this one that doesn't work, if we have a 15, a 10 and a 1, you can see that 10 plus 1 is not greater than 15. So it can only work when 2 sides are greater than the third. So these are the properties of the triangles that will work. And we want ones that are isosceles. So let's just square them off. Isosceles will have 2 sides the same. One is fixed at 10. So we could have this one, a 10, a 10 and a 6. And I think the only other one making an isosceles will be an 8, an 8 and a 6. So there's 3 answers. We can have an 8, a 6 or a 10 for this part. They've given what looks like a quadratic here in part C, and we're told the graph below shows the area of the triangle for all values of x between 3 and 13. You can see 1, 2 don't work here, between 3 and 13. 3, we said it was going to be a flat line, so the area is 0 here. You can see this will be representing area. And at 13, we'd also have a flat line, it will be 0, 2. So we have a point A, and we're asked to estimate the area here. So it's at 4, as you can see, we're told. So if we go left from the point, it looks like it's just below 19 here. You have a ruler on the exam. The range here that you were allowed in the exam was 18.5 to 19 for full marks. So somewhere between these two values for area. Parts 2 and 3 were to plot point B on the graph to represent the triangle in B. That's where x is equal to 9. And the graph is symmetrical. Draw the axis of symmetry of the graph and write down the equation of the axis of symmetry. So let's have a look at those two on the graph. Point B, x equal to 9, and the axis of symmetry. So on x is equal to 9, we are approximately here. If you come left from there, looks like it goes to just over 30 but less than 31, and the exact answer is 30.5 for this one. The margin given was plus or minus 0.5, so 30 to 31 was for full marks for plotting point B. And then the axis of symmetry, you can see, is at this line here. X is equal to 8. So the equation of this line is just x is equal to 8, very simply. So the 3 points, the 3 parts of this, part 1, 2 and 3, were all worth 10, were worth 10 for all 3. So we had 9, 30.5, and x equals 8, kind of a clue that the box is tiny. It's not the full equation of a line. And then the last part of this question, big surprise, see Pythagoras in part D, showed that the triangle is not right angle when the sides are 10, 5 and 11. You could sketch it out, but we, Pythagoras at this side, a squared plus b squared equals c squared. Equals c squared. So c is always the biggest side, so you can put that one in there. 10 squared plus 5 squared is equal to 11 squared. So 100 plus 25, is that equal to 121? It nearly is. 125 is not equal to 121. Therefore, not right angled. And the diagram below shows the triangle with the biggest area. And this was the max, the vertical line that we drew a minute ago, the symmetry of the graph, and we're asked to work out the area of this triangle. There's a clue in the question here. Give your answer in this form, 5 root n squared. So again, part E was not very well answered, so they gave 10 marks for 2 parts, 8 for 1 fully correct and 2 for 2 fully correct, but really what they're doing is giving 8 for part D. Just drop a line down here. Now you've got a 5 down the bottom, and we can work out using Pythagoras. Draw my new triangle. We've got an 8, a 5, the square root of 8 squared minus 5 squared is equal to, just type it into your calculator, 64 minus 25 is 39. And then we use half the base, half of 10, by the perpendicular height, which we've just got to be root 39. We'll give 5 root 39 cm squared. And that concludes question 7 and this video.